the transient and steady state analysis of linear DC circuits. Hello everyone, my name is Rafael, I'm an electrical engineer, and in this quick video I would like to discuss with you the transient and steady state voltages and currents of linear DC circuits, and to do so I chose this problem here. I took this simple question from my civil service exam of my home country and I decided to translate it to English to show to the world how electrical engineering exams are like in Brazil. To follow, go to the description of the video. Let me read the problem. The circuit of the figure is an RLC structure powered by a DC voltage source and a switch. At the moment the switch closes, T equal to 0, the capacitor and inductor are de-energized. The switch is then kept closed indefinitely, T going to infinity. What are the initial and final values of the currents through the inductor, ILT equal to 0 plus, and IL of T going to infinity, and the voltage across the capacitor, VC of T equal to 0 plus, and VC of T going to infinity. Okay, so this is the problem, and then we are going to solve it right now. Firstly, we are going to calculate the values for T equal to 0 plus, the current in the inductor and the voltage across the capacitor. So, at the moment the switch K is closed at T equal to 0, at T equal to 0 plus, what happens here? The inductor behaves as an open circuit. Okay? At the moment the switch is closed, the inductor behaves as an open circuit. The current will not pass through the inductor. And at the moment the switch closes at T equal to 0 plus, the capacitor behaves as a short circuit. Okay, so what does this mean? It means that the current through the inductor at T equal to 0 plus has to be equal to 0 amperes. Okay? Because the inductor has inductance, and this inductance prevents the current from passing through it immediately. And how about the capacitor? The capacitor behaves as a short circuit. Okay? So, all of this voltage here, all of the voltage of the battery is going to be on top of the inductor. And this pole here is going to be felt here. This terminal here is going to be felt here because the capacitor is behaving as a short circuit. So, at T equal to 0, this terminal here is going to be felt here. If you put a multimeter here, you are going to feel this terminal here. And the voltage across the capacitor is 0. VC of T equal to 0 plus is equal to 0 volts. Okay? Now that we know this, we have solved this part here. And we need to solve the other part. This is going to be a very quick video. And then at T going to infinity, this reverses. The inductor now behaves as a short circuit and the capacitor as an open circuit. Okay? So the current that's going to pass through the inductor is going to be IL of t going to infinity is equal to 20 volts divided by 10 ohms. Because the capacitor now is an open circuit. The current is not going to pass through the capacitor. The voltage is going to pass through the inductor and the resistor. 10 ohms. And this has got to be equal to 2 amperes. Okay? We are almost over. And can you see that the capacitor is in parallel with the resistor? Then what happens is that the voltage across the capacitor at t going to infinity is also equal to the voltage over R1, which is equal to 2 amperes, because we discovered that the current here is 2 amperes times the resistance, 10 ohms. And this is equal to 20 volts. So, it was a very quick video, and we discovered that IL of t equal to 0 plus is 0 amperes, and the VC of t equal to 0 plus is 0 volts. And at t equal to infinity, IL of t is equal to 2 amperes and VC of t is equal to 20 volts. So my friends, this was the video that I wanted to make. I hope you learned from it, and I hope you see that it is indeed very simple. If you want to contact me, simply leave me a message in the comments of the video, or you can contact me via my WhatsApp number. I'm gonna leave the number in the description of the video, alright? So, goodbye!